let us discuss the chapter practical geometry. Now you have already know that how many measurements are required to construct a unique triangle. So we know that 3 measurements like sides or angles are required to construct a triangle. So we can write that 3 measurements means sides, angles, are required to construct a unique triangle. Now naturally a question arises that how many minimum measurements are required to construct a quadrilateral. Now let us check how many measurements are required to construct a unique quadrilateral. Now for this we will do an activity. Now take 2 sticks of equal length, so like 10 centimeters and 10 centimeters, and take other 2 sticks of equal length like 6 centimeters and 6 centimeters each. Now let us arrange all these 4 sticks in such a manner that we get a rectangular shape. A, B, C, D. Here the length of the stick AB is 10 centimeters and the length of the stick BC is also 10 centimeters, and the length of the stick AD is 6 centimeters and BC also 6 centimeters. Now we got a rectangular shape. Now do one thing, just push the rectangular shape along its breadth. Now you will get the shape of a parallelogram. If you push the rectangular shape along its breadth, now the rectangular shape became a parallelogram shape. Now the measurements are the same in this case of parallelogram. So without changing the measures of each side, a rectangle became now a parallelogram. So we can understand that the 4 measurements are not sufficient to construct a unique quadrilateral, because here the 4 measurements in case of rectangle and in case of parallelogram are same. See here AB is 10 centimeters, in case of parallelogram also AB is 10 centimeters. So all the measurements are same, but a rectangular shape became a parallelogram shape. Now if you push once again in the opposite direction, so again the shape of the rectangle is changed. Now also it is a parallelogram but in different shape. So in this case also the measurements are same. So without changing the measurements of each side, a rectangle became a parallelogram. Means here also we can understand that these 4 measurements of the sides are not sufficient to construct a unique quadrilateral. Now let us introduce another measurement whose diagonal is given. Now let us take another stick by joining the vertices B and D. Now here the length of each side remains same. So if you take another stick as the diagonal joining the vertices B and D, now there are 5 measurements including AB, BC, CD, DA and the diagonal BD. Now if you push the rectangle, then its shape will change, or its shape doesn't change, but it may open. So but the measurements will be the same. So we can understand that, so 5 measurements are required to construct a unique quadrilateral. So we need 5 measurements to construct a unique quadrilateral. So we can write that 5 measurements are required to construct a unique quadrilateral. Now let us discuss constructing a quadrilateral. So you already know that 5 minimum measurements are required to construct a quadrilateral. Now let us check which 5 measurements are required, either 3 sides 2 angles or 2 sides 3 angles. So now let us discuss this thing now. So a quadrilateral can be constructed uniquely when the first case 4 sides and 1 diagonal are given. And the second case 3 sides and 2 diagonals are given. And the third case is that 2 adjacent sides and 3 angles are given. And the fourth case is that 3 sides and 2 included angles are given. And the fifth case is that some special properties are known, means in case of a square or in case of a rectangle or in a rhombus. Some special properties are known. So we can construct a unique quadrilateral. So when 4 sides and 1 diagonal are given, and when 3 sides and 2 diagonals are given, or 2 adjacent sides and 3 angles are given, or 3 sides and 2 included angles are given, or the last case is when you know some special properties. So these are the different cases to construct a quadrilateral uniquely. Now let us construct the quadrilateral in each of the following cases one by one.